This month's topic from our series is TPM, Total Productive Maintenance. And we're going to learn about how this process works, how it's been successfully used in the industry. And it's more about getting your operators involved in helping maintain and operate your plant effectively. But you can see from our PF curve here, TPM is one of those processes in the proactive part of the curve. And it's very important that we understand this process and what the benefit of this process is to the reliability of our plants and the continued success of our plants is using our people effectively. We're going to talk more about people next month when we talk about the topic of you win with people, and it's more about, getting your people and how you effectively use your people. But this is the process that's been used around the world in many different companies. But it's a company-wide team-based effort to build quality into equipment and to improve overall equipment effectiveness. What it involves all employees. I mean, you can't have a TPM process that just involves supervisors and the way we manage people. It aims to eliminate all accidents, defects, and breakdowns from our process. So, a full TPM blown program, we're looking at all these different areas that we can control. It's productive. Actions are performed while the production goes on. So this is not something we have to shut down for. This is not something we have to reorganize or retool our plan for. But, troubles from production, we're trying to minimize all those issues that come up from production problems. Maintenance-wise, it's keeping equipment in good condition. And how do operators help us repair, clean, and lubricate, do some of these tasks that are involved in maintaining the equipment? So TPM combines the traditionally American practice of preventive maintenance with total quality control and total employee involvement. So we talk a lot about, people think that TPM is just getting operators involved, but we're trying to train those operators not only to do some maintenance tasks for us, but also improve the quality of their products and the quality of what they operate. It's to create a culture where operators develop ownership of their equipment and become full partners with maintenance, engineering, and management. Many plants I go to, one of the biggest problems is when a piece of equipment breaks, you hear the comment, well, it keeps breaking because maintenance doesn't maintain it correctly. And operators, or maintenance people say, well, it's breaking because the operators don't operate it effectively. But how do we get these two groups working together to be more productive and get more out of our people and out of our equipment? Dr. Deming wrote the book, The 14 Steps of Quality. And he introduced statistical analysis and used the resulting data to control quality during manufacturing, which is called TQM. TQM is part of the TPM process. Some general concepts of TQM, did not work well in the maintenance environment. In fact, it wasn't even accepted here in the U.S. You had to go to Japan to get this process to actually prove the process worked. The need to go further than preventive maintenance was quickly recognized by companies who were committed to total quality management. So we can't, a lot of times, get the quality and get the operations we need just by doing maintenance. It takes a bigger part of our people and process to make this happen. But it says here, maintenance became an integral part of TQM during the early 90s. So TPM is based on the following principles. Total quality management. Again, process developed after World War II, adopted by the Japanese after World War II to prove to the world the quality of their products. The process was a major part of Deming's principles. I read this book back in the late 80s, early 90s, the Deming's 14 Principles of Quality. I had all my supervisors at the plant that I was at. I bought them copies of that book and had them read the book. Yeah, some concepts from the 70s and late 60s, but they're concepts that actually helped our plant improve when we started looking at these concepts and how they apply to the processes and even nowadays. So if you've never read the book, never looked at the book, it's a very, very good book to read. But TQM is a belief that all employees contribute to small incremental improvements to product quality each step of the process. The process today has grown to encompass all aspects of a business. So again, it's getting employees to contribute, every employee to improve what they do to improve the quality. The ultimate goal in total quality management is 0 defects. Now, can we ever get to 0 defects? You have things like Six Sigma and other processes that go on, but that's really what the goal is Very few companies get to 0 defects, but the key is reducing those defects to something that's manageable. You know, and in some companies I get into, when they get down around only 2 or 3%, that's what their goal is, and they're happy with that. But it's again, what is the goal? Is it 0 defects or is it some other number? The management style in TQM culture is participative, trusting, and focused on fixing defects and solving problems with the whole team. It's not all done through root cause analysis with a small group. Now, here's a key part of the process in TQM or TPM the same way. The process does not focus on blame. So one of the early companies I visited in 2005 was a Toyota car plant in Tennessee here in the U.S. Very big on TPM. And what the process they use there is every operator, every maintenance person came in and went through 4 to 6 weeks of intensive training. So the operators would go through intensive training on the equipment they were going to operate, excuse me, the process they were going to operate. So they knew everything mechanically about the process. They knew everything electrically about the process. They knew the PLC system that ran the process. So when they were put on the floor to operate that equipment, they knew everything about it. And once they went out on the floor, the company basically told them, this is yours. You operate it. You tell us when you need help. You tell us when you need redesigns. You tell us when you need maintenance. But in this culture with management here, if anything happened with maintenance or operations at that facility, the maintenance and operations people were never at blame. 100% of the blame was on management because they were so convinced of the way that their training went in their people that management took 100% of responsibility for everything that happened at that facility. A whole different culture than the way we do it at most facilities today. So in TQM, total quality measurement, information is shared and the people let the data that is gathered lead them to make further improvements. So a lot of times information about and the data we collect is used by reliability engineers, it's used by supervision, but all data collected in this is shared by everyone all the way down to the operator maintenance people so that they can see what's going on and help. You know, one of my big customers started a TPM process and a reliability process years ago. They measure OEE every shift, and every shift they make corrections to improve their OEE. This one company in particular moved from a OEE of 52% in 2006. Today they're at 93.1, and it's all because everybody's involved in the process. But the largest effort in any process is gathering, recording data, and then using the data to improve your process. So again, a lot of times when me and my son go in and do audits, they don't have any data. They're not collecting. Like, they can't tell us what equipment fails more often. What's the reason of the failures? So we have to collect this kind of data to make improvements in our process. You know, some of the things with TQM is about quality, output and the effects of the output. You know, TPM is about equipment, so it's input and the cause. In TQM, we need a management system that's software-oriented to keep track of all this data. We're tracking quality in parts per million or parts per whatever the unit's going to be. But in TPM, it involves employee participation, and it's hardware-oriented. How do we maintain the equipment? And it's elimination of loss and waste using people. So some principles of TPM. We want to increase or improve overall equipment effectiveness. And like I say, well, I've got numbers from some of my customers where they were able to be very effective at this. And we'll look at OEE in a few minutes here in the slide presentation, but it's a very effective process. And used effectively, it becomes a leading indicator instead of a lagging indicator. You know, it improve existing planned maintenance systems because we're getting more input. The operator becomes an accurate condition monitor. So in TPM, we'll talk about autonomous maintenance here. The operator is actually trained to recognize failures, and he becomes one of those condition monitoring tools we have in our facilities. An example of one of my customers, they go down every 3 months for about 2 weeks to rebuild their systems. During that time, operators are available, so we use the operators in training classes. We train the operators on every single component in the system. We train them on the failure modes of motors, bearings, belts, shivs. And these operators, understanding how these equipment can fail, became very, very good troubleshooters. So they could actually call maintenance and say, this is what's happening, this is what I need. And this is what drove that plant to that 93.1% OEE. We have to provide training to upgrade operations and maintenance skills. We want to improve everyone and utilize this cross-functional teamwork, which get maintenance, engineering, operations all working together and talking together effectively. You know, the major pillars of TPM, autonomous maintenance. Anytime we see the word autonomous maintenance, it's maintenance performed by the operators. So very important function of TPM. Plan maintenance. We can plan more maintenance. We talked about earlier in the year with predictive tools, but now we can plan more maintenance because we have more accurate input from the operators. Equipment and process improvements. Again, something we do as a team with our groups. Early management of new equipment. And when new equipment comes into your plant, a lot of times what we do, we put it on the floor, we start operating it, and we have to manage some of those things with the new equipment. So what kind of process do you have in place to do that? Process quality management and TPM in the office. Now, TPM in the office is good in some locations. It's been an issue in other locations. And this is where you get some things going on with your office people, but there's some good concepts of TPM that you can use in the office area. We won't cover any of those today. But again, you see some of these things down the bottom. To do all these things, it takes education and training. And again, we can't miss on one very important tool across the bottom here, and that's managing our safety and environmental as we're doing the TPM process. So again, autonomous maintenance. Train the operators to close the gap between them and the maintenance staff, making it easier for both to work as one team. And this is a big culture change in many, many facilities I go into, is getting these operators and maintenance teams working together and communicating effectively. But the more we train, the more they understand, the easier this becomes. We can change the equipment so the operator can identify abnormal conditions and measure deterioration before it affects the process or leads to failure. Sometimes we have to buy the operator's tools. And I can remember an example of this was at a facility I was at where they had lots of V-belts and lots of shivs that were actually moving the product down through the system. Well, how can we ask an operator to do PMs or inspections on that while the system's running? Well, we bought the operators a strobe light. So now the operators with a battery-powered strobe light could stop the belt, see the condition of the belt. They could shine the strobe light into the shivs, see if the shivs were worn out. We could see if belts were shiny from slipping. So now the operators with these tools were able to look and detect failures that they could report to maintenance before the belt just actually fails or starts slipping. So how do we change the equipment so the operator can identify these conditions? Sometimes we have to put inspection ports in for them to do this. But autonomous maintenance says there's 7 steps that are implemented to progressively increase an operator's knowledge, participation, and responsibility for equipment. Again, sometimes it's performing this initial cleaning, because sometimes we can't effectively inspect unless we can clean the equipment. What are the countermeasures for the causes of effect of dirt and dust? We have to train on that so the operators know what to clean and how to clean it. So then we establish some cleaning and lubrication standards. You know, many of my facilities that are using TPM have developed some lubrication tasks that are performed by the operators. You know, conduct general inspection training. What is the operator supposed to look at? What is his inspection supposed to be? Then how do we carry out those inspection checks? What's his checklist? What's he looking for, and how does he report back? Workplace management and control. This is where management comes in, and we get some of these things done. And then it's just continuous improvement. How do we get these operators to become better with each step of the system of autonomous maintenance? You know, equipment and process improvement. What's the objective? Maximizing the efficiency by eliminating waste and manufacturing losses. You know, manufacturing losses are categorized into 13 big losses: equipment losses, manpower losses, and material losses. So what do some of these things involve? Well, these are like OEE, they're downtime losses, equipment failures and breakdowns, you know, setups and adjustments. If those are done wrong, we have equipment failures. Speed losses, you know, minor stop and idling, reducing the speed. And then we can have quality losses. Are those process errors, rework, and scrap? Those all fall into this equipment and process improvements. Our manpower losses, cleaning and checking, waiting on materials to come, waiting on instructions, waiting on quality confirmation. These are all things that are manpower losses. And then we have material losses. You know, your yield, your energy losses, your consumable material losses all fall into those categories. So overall equipment effectiveness, we talked about this earlier. Some of you guys understand the principles, and some of you may be using this. Some of my customers use it very effectively. Like I say, one of my customers, they measure OEE per shift. So they know exactly what's going on, and they know exactly what to go and check on and correct at the end of every shift. So here's overall equipment effectiveness. It's availability of your equipment. You know, if you say we're supposed to run 100 hours a week and you only run 90, your availability is only 90%. Performance, which is your speed loss. So if we're going to run 100 units a week and we only run 90, your performance is 90%. And then our quality. You know, if we say we want to have 100% quality, we only have 90 for the week or 10% losses, our quality is only 90%. So this breaks down what equipment, our overall equipment effectiveness is. So availability is the time available for production minus the downtime divided by the time available for production. So whatever downtime you have in there affects availability. Your performance is like the number of parts produced. And then we've got these quality problems. But you can see when we multiply these three things together, so if we have 90% availability, 90% performance, and 90% quality, our OEE is only 73%. So lots of room for improvement in each of those areas if you have those issues. So how do you get overall equipment effectiveness to 96%? It's a lot of work and a lot of time. So again, a lot of companies I deal with, they set a goal of 86% OEE because they're much worse than that. So lots of companies say we can't be below 86. So how do you get there? You know, what is planned maintenance? So establish preventive and predictive maintenance systems for your equipment and tooling. What is the natural life cycle of an individual machine else must be achieved? Correct operation, correct setup, cleaning, lubricating, sometimes retightening, feedback and repair of minor defects. You know, the quality of your spare parts. Who is going to be responsible for each of these areas? The operators can do some of these things, and maintenance is probably going to be responsible for some of these things. But how do we balance this out for our facilities and our individual piece of equipment? The objective, early management of new equipment, establish systems to shorten new product or equipment development, startup, commissioning, and stabilization time for quality and efficiency. And this is one that I just finished at a facility in Canada where we looked at some of these things that were going on in the startup commissioning and how we're going to make the equipment do what it's supposed to do. So new equipment needs to be easy to operate. Many things they had weren't. It needs to be easy to clean because cleaning helps us find defects. Easy to maintain and reliable. A lot of times maintenance and operations are not involved in the design, in the engineering, so things aren't easy to maintain and they're not reliable components. Can we design things with quick setup times? This is very important in the food and pharmaceutical business sometimes where they're changing products and they're changing containers. And again, how do we do this one? Operate the lowest life cycle cost. Again, this is one of the things we covered in an earlier webinar, but very important to understand what is the life cycle cost of your equipment. Sometimes the life cycle cost of some equipment is more or less, but it costs more. So where does that balance? We're going to talk about this in a webinar in our 2018 series. How do you determine life cycle cost? Process quality management. What's the definition? A process for controlling the condition of equipment components that affect the variability in our product quality. Objectives, set and maintain conditions to accomplish zero defects. How do we do that with each piece of equipment or each process in our plant? Something, again, it's a lot of teamwork involved in that. Quality rate has a direct correlation with material conditions, equipment precision, production methods, and whatever process parameters we set for the equipment. So how do we do this with the systems we have? TPM and administrative and support departments. Administrative and support departments can be seen as process plants whose principal tasks are to collect, process, and distribute information. And this is very important in TPM is how is the information on what we're doing, what we're trying to accomplish, how is that information gathered, and how is it distributed to everybody to know that we're doing things right. Some of the facilities I have are very good at that, maybe have too much information, but they're collecting a lot of data. And sometimes the data tells us what we're doing and where we're going. but it says process analysis should be applied to streamline the information flow. Again, not too much data, not too little data. How do we balance that? So education and training, and this is a key component here. TPM is a continuous learning process. And a lot of times, process is something that we always want to look at. If we have processes like the reliability process, it's something that never ends. It's always continuing. You know, two major components of our education training is what we call soft skills training. You know, how to work as a team, diversity training, communication skills, because this is one of the things that's a real culture issue at many of the facilities I go to, and especially at union facilities, where how do you get different groups from maintenance, production, engineering, supervision to work as a team? How do you get rid of some of these diversity issues you see in some of the facilities I go into? Well, a lot of it's we have to figure out how to do this, because TPM is a plant-wide, it's a company-wide effort. And then we have this technical training. How are we going to do technical training? You know, upgrading problem-solving, equipment-related skills. That, to me, and the biggest success I've had with that is making sure that maintenance and operations people understand every detail about how their components can and have failed. Once employees know about how components can fail, they know the failure modes, a lot of times they become better problem solvers. You know, whenever I do RCM analysis or failure modes effect analysis, the biggest bang for the buck with those kind of processes is operators and maintenance involved in an RCM analysis come out of the analysis knowing every single detail about the components and about the different equipment in the process. They're very educated. So this is one of those technical training things we have to figure out how to do. And again, with anything we do in our facilities, safety and environmental management, you know, assuring safety and preventing adverse environmental impacts are important priorities of TPM. They're important priorities of RCM, RCA, any of the processes, because like I say in every training course I do, sometimes we can calculate the cost of downtime. We can calculate the cost of lost product, but there's no way to calculate the cost of a safety or environmental incident. You know, just ask BP about some of those incidents with like Texas City and the Gulf oil spill. You know, billions and billions of dollars in fines and lost life and lost equipment. How do you calculate some of those things? How do you plan for safety and environmental incidents? We can't. You know, if somebody loses a finger or has a serious health problem from something we do, what's the cost of that going to be? It's really hard to put a number on that, but there are biggest cost failures we can have in any facility. So 3 requirements for fundamental improvement: increasing motivation. How do we change people's attitudes? How do we change the way people think? Very hard to do. How do we increase competence and people skills? Well, that's through training. You know, a lot of the things we did at the company I worked for to develop our training programs was doing skills audits. How do you go out there and assess the skills of your people you have now to determine what you're going to train on? Or do we just randomly pick a training program and train everybody on everything? Well, sometimes a skills audit is very important to develop the training program we're going to use for everybody. And then sometimes it's important to narrow it down. Now, one of the things that me and my son do, we do the CMRT exam. It's an exam certification for the maintenance technician put out by the Society of Maintenance and Reliability Professionals. This exam is, they take a 175 question exam on 4 different body of knowledge areas. And from that exam material, the employer and the employee get a result of 22 different areas, which actually rates that employee's skills. And then from that document, then they can develop training programs. But again, in order to effectively improve or implement TPM, we have to have some skills training. Now, do we need to improve the work environment? How do we do that? So it supports the establishment of a program for implementing TPM. So what is the work environment? You know, do people get along? What's the working conditions? So some of the things we have to look at to get a TPM program up and going or plan for the future. So here's some 12 steps to TPM. Preparation, the announcement to introduce TPM so everybody understands what it is. Now, one of the bad words in the back of that is maintenance, right? And so, at one of the facilities I worked at, when we did all the training on how equipment fails with the operators, one of the things we had to remember was operators in a union plant, they do not do maintenance. So we can't use the word maintenance. So how are you going to announce TPM without using the word maintenance? Is it total productive manufacturing? One of my customers, they used the term OE. It was operator involvement in the program. So it was operator things that we did. We didn't use the word maintenance. Introductory education campaign for the work program, letting the workforce know what kind of training, what kind of education they're going to have to go through. Special committees. How are you going to get people in these committees to help with the process? And it's going to have to be some of your operators of maintenance. What are your basic TPM policies and goals? And how do we prepare and formulate a master plan? So some of this stuff's got to be done up front. And a lot of this stuff's done up front before you ever, get the employees involved. Now, do we invite customers and affiliated companies and subcontractors to be involved in the kickoff? The kickoff of TPM is a big event, so everybody knows everybody's involved. Then implementation, develop an equipment management program, develop a planned maintenance program, your autonomous maintenance program. How are we getting the operator? What are the operators going to do? And why we want them to do it, and why they're going to feel good about doing it? How do we increase the skills of production and maintenance personnel? And I get this argument, well, my maintenance people are already trained. I just need to train the production people. Well, I don't really find that out in these plants I go to. There's training that needs to be done for maintenance and operations, production people, so that we get the TPM program working correctly. Develop an early equipment management program, especially when you're bringing in new equipment and new processes. And how do we stabilize the TPM program? Perfect TPM implementation, raise the TPM levels. So lots of things we got to do here, for a TPM program. So again, here's what some of them: state the TPM objectives in a company newsletter. Place articles on TPM on the company newspaper, hang them on the bulletin boards around the plant, so people start understanding the terminology and what we're trying to accomplish. And really, we're trying to accomplish better quality products and more customers in the end. What's this introductory campaign? Seminar for the managers. Managers have to understand all this. Slide presentations for all the employees. Where do we get those? Who's going to develop them? Verify understanding of the process and goals of TPM. Very important to get this out to your people. So how do we do that? Newsletters, articles, videos, posters. There's lots of that stuff available in the industry. Lots of good companies and consultants in the industry to help you develop some of this material. Because TPM is not one of those things where we just go out and say, next week we're starting TPM. It doesn't work that way. It's a long process of getting people to understand what it is, how they're going to be involved, why they're involved. How do we do that? A lot of these methods right here. What are these basic TPM policies and goals? Analyzing existing conditions, understanding what you're doing in your plant now, what conditions you want to change, setting some goals. We never want to say, by God, we're going to have this done by next month or next year. One of my customers was a major aluminum recycler in the U.S. that was a strong union. It took them 5 or 6 years to get TPM up and running. Another one of my customers that took 2 years. So set some goals. What are these different steps and how long it's going to take? Can we predict the results? Well, I hope so. We want to know what we're going to do. That. How do we measure and track the data? How do we know what's going on? How do we know when we're improving? Again, we have to collect some data. Who's going to develop the master plan that lays out the goals? What are you really trying to achieve, and how are we going to achieve those results? Again, the master plan is very important for TPM. So the detailed plans for each pillar that we looked at has to be prepared. So again, it's just not something we can run out there and start tomorrow. How are we going to organize all this up front even before we present it to the employees? And basically get the employees involved and help them prepare this. The TPM kickoff. The main kickoff to TPM should take the form of a formal presentation with all employees attending. This is an opportunity that can be used to gain full support of the employees, but it has to be done right, or you get some negative attitudes right away that I have to do more, I have to work more hours, I have to, whatever it might be. We don't want any negative things coming out of this. Invite some external customers. Let the external customers tell your employees why this is important to keep them as a customer. Do you have some subcontracting companies you use? Why TPM is going to be important for them? So again, the kickoff's a very important event. What is your equipment management program? What are the tools of quality management, continuous improvement? Form project team to work on issues. Employee involvement is the key. We have to have all the employees involved. One of my main customers that started this process, there was a meeting a TPM meeting every week. There was 3 or 4 operators involved. There was 2 or 3 maintenance people involved. Just a half hour to an hour long meeting. And this part of this is you're getting this information. How do I identify my equipment problems I'm having now? Get these people involved in analyzing the equipment problems. What are we going to do? Then we got to develop solutions and proposals for improvement. So it gets everybody understanding how we can improve the equipment processes, what we're going to do. So it's very important to get everybody involved in this. A typical membership team at TPM, 5 to 7 operators. Now that's at a large facility. Your smaller facilities may be 2 or 3. Maintenance personnel, how many? It has to be somebody that's familiar with the problems you're going to talk about. Maybe you need to bring in a technical expert, an OEM. Predictive technologist, somebody that's familiar with kind of the failures you're having. All good members of a team when you're working on problems. What kind of tools we're going to use? Maybe some Pareto charts, some cause and effect diagrams. Maybe we have some root cause information, or maybe we do a root cause analysis right in the meeting. Why are these failures or problems happening? But some kind of methods analysis so we know what we're trying to correct or eliminate a problem. But again, getting these people involved is the key. So it says total productive maintenance. And I like the term total productive manufacturing better than I like the word maintenance. Is an approach to managing physical assets that emphasizes operator involvement in total equipment care. And this is the key thing about TPM, is getting the operator involved. You may not be able to take it as far as Toyota has, where you give the operator his machine, give the operator his responsibility for operating and quality, and you take the blame when he's not right. You may not go that far, but it's something you want to work for. But it pays dividends in making equipment more reliable. Develop a planned maintenance program. Set up plans and schedules to carry out work on equipment before it breaks down. And remember we talked about this in our PM discussion, in our PDM in our PDM webinar. Include periodic and predictive maintenance. We have to do this. This is part of our planned maintenance program. Also part of this is include management of spare parts. Now, one of the things we're going to talk about in one of our webinars next year is spare parts, how to determine what spare parts we need, what are critical spare parts. So it's going to be an excellent webinar on spare parts. But it's a very important strategy. One of the plants I'm working at in Canada right now, we've done the asset criticality. Now we're just going through and making sure we have spare parts for our critical assets. And we found out that there's many critical assets we don't have spare parts for, but it gives us a way to start. How do you develop an autonomous maintenance program? Now, are you going to call it autonomous maintenance at your plant? Are you going to call it operator care program? If you have a union plant, it's going to be tough to call something maintenance, but can we call it operator care? Promote the 7 steps. Tasks to hand over to operators, cleaning. Because remember, I said we got to clean sometimes to find issues. How many tasks can your operators do in the area of lubrication? And sometimes we say, well, my operators, we don't want to perform lubrication because they're going to do it wrong. Well, the only reason they would do it wrong is because they're not well trained. So how are we going to get operators to do some of the lubricating tasks? What about inspecting? Like I said, we bought the one group of operators a battery-powered strobe light. $250, $300, but now these operators can actually go out there and inspect V-belt wear. They can inspect shivs for wear. They can inspect keyways. They can inspect set screws while the machine's operating because we gave them a tool to do inspections. I've given operators laser temperature gauges. So now they can just walk around, take temperatures of bearings and critical components. have your operators really been set up? Now, one of the plants I was at where they wrap crackers, every time they changed over to a different style of cracker, different style wrapper, the maintenance person came over and set the machine up and did all the adjustments. Well, there's no reason. The operators there were more than intelligent enough and more than capable enough to set up their own machines and do these adjustments. What did it take? A little bit of training. And now the maintenance man is freed up to do some other more critical tasks. Training sessions. How do we improve the skills of production and maintenance? It's all about training. You know, if you look at the worldwide or the world-class metric on training, it says that every person should have 80 hours of training per year. Now, that's a lot of hours. Very well, I'm going to say none of the facilities I do work with put enough effort in to get 80 hours of training per person per year. So how do we do that? What's the right number? Well, you got soft skills training, which are those things we just need the people to do daily. But then how do we do the technical training? Train leaders together. This is something I try to do. I try to have management, supervisors, engineers when I'm doing the training with the operators. We don't want to train the operators on something that something that an engineer or a manager doesn't know. And we don't want to train managers and engineers and supervisors in things that the operators don't actually know. So how do we train everybody together? Now, a lot of times at plants, I go in and train the leaders, and then they pass the information down. But how effectively is the information passed on to the actual employees and the group members? Again, with good training and good training materials, we can make sure this gets done effectively. Now, this is something that many of us don't do, but you know, the principle of designing for machine prevention can be applied to new products and new existing lines. So if you have new product lines, make sure they're designed so they can easily produce or easily maintain. And again, this is something I do webinars on how equipment fails or why equipment fails. Most of it goes back to design and engineering. A lot of the operations, I was at a plant where they used what's the term? They use lean manufacturing. They put all the machines in, they maximize the use of floor space and the use of products. Well, when the motor went out on the first machine, the maintenance guys were unable to get the motor out without taking the machine completely apart, sliding it out in the aisleway. So again, we didn't design it for easy operations and easy maintenance. But again, it's something we have to get maintenance and operations involved in all these things. Sometimes a young engineer or an engineer doesn't look at some of the things that have to happen when that machine fails. You know, existing machine, analyze historical records for the type of failures. Again, this is something that is not done very well in CMMS systems. I'm going to do a webinar next year on effective use of CMMS systems. I'm going to bring in some other speakers and other experts next year for some of the webinars. But again, how do we keep track of this data? And again, when I go into a plant, they're having lots of failures, I say, all right, so what type of equipment components failing the most? Where are you spending most of your maintenance time? Well, a lot of the times it's guess. They're just making assumptions. They don't have data. How frequency is the components failing? What's the root cause of failures? We're not doing root cause analysis. So the only way to determine how to eliminate problem and reduce maintenance, you know, is by tracking all this data. And so how effectively are we tracking it? Does everybody know what components fail the most and why are those components failing? Is it a lubrication issue? Is it an alignment issue? Is it an operating procedure? We have to know these things. All right, so perfect TPM implementation raises TPM levels. So evaluate the PM award. You know, the Japanese Institute for Productive Maintenance runs an annual PM Excellence Award where they provide a checklist for companies to apply for the award. So you can actually apply to get an award in TPM. This helps you set higher goals when you're actually looking at all the things that are on this checklist for a TPM program or this annual PM Excellence Award. So again, this is something you can download and see where you're at. The benefits of TPM. The key one, increase equipment productivity. That's what we're trying to do. Reduce equipment downtime. Increase plant capacity. This is what happens. A lot of times we lower maintenance and production costs because we're catching these failures before they become major failures. Can we approach a zero equipment cause defects? You know, this is something that, you know, and here's what sets the example. In that Toyota plant that I talked about, There was a timer at every machine. So when that machine went down and stopped producing, the timer went off. And it started timing how long the machine was down. Well, it was timing in tenths of a second. And when they reached 2 minutes of downtime on any piece of equipment on the line, it called for a full root cause analysis. That's how effective and efficient they were. 2 minutes of downtime was a full root cause analysis. They had very little downtime at this plant. So they were trying to get to this zero defects. It enhanced job satisfaction because now people learn more. You know, one of the things I was told at this union plant when I was training operators on equipment failures, they actually told me, well, most of the operators aren't going to care. They're not going to listen to you. Well, in doing the training, they were all interested in how their machine actually works. They were all interested in how to go out and do inspections. I would send them out with cameras and notepads, and I said, go out and some of the failures we talked about. Take pictures and find failures. You wouldn't believe the number of failures and defects they found in just going through their equipment once they recognized or understood how their components fail. Improve return on investment. This is the key one. And this is the one I stress with RCM and other processes. Improves the communications between operators and maintenance. One of the biggest benefits is now operators and maintenance people can talk intelligently and effectively with each other about their equipment. TPM creates an environment that encourages operators to commit to overall equipment care. You know, one of the questions I always ask, can you teach the caring of equipment? Well, if we create the environment that encourages that kind of care, yes, we can teach caring of equipment. A lot of times it's all about engagement, which we'll talk about next month when we talk about how to effectively use our people. It's all about engaging them in these processes. But again, TPM, a big process. It's not just a process we can go out and say we're going to start this tomorrow. You know, it's about asset strategy. It's about empowerment. Who are we going to empower in this process? It's about resource planning and scheduling. What are our systems and procedures we need to develop? How do we measure? Remember, one of the things I talked about was we measure to collect data. And from the data, we could have continuous improvement. So it's just a big cycle. So TPM process leaders, champions, steering committee. So as to become effective at TPM, you must understand and practice many techniques to predict, prevent, and eliminate failures, which we talked about some of these over the course of the year. Failures can be equipment, failures can be personnel, failures can be in your supplies, or failures can be in your procedures. Where are most of yours coming from at your facilities? I'll repeat this many times. Move slowly and decide what techniques work best. This is not a process where I'm going to have full-blown TPM at my facility by the end of the year or even in a year. Move slowly. Plan your work out well because it can become one of those processes that upset people, that alienate people. So we have to move slowly with this process to make it work the best. Your equipment improvement teams. One of the key steps we have to do early is don't try to do this with supervisors and engineers. The huge part of the success of this is buy-in. So get everybody involved. You know, if you're running a TPM group, you're the facilitator for the group. If you know what the answer is to the problem, you don't want to tell them. You have to get people involved in figuring out the answer. You're a facilitator. Guide them to the correct answer. Because don't bring people, your operators and maintenance people into a TPM meeting and say, well, this is the problem we're having, and this is what I want you to do to fix it. Get the input. Get them involved. TPM is a change process. Everyone in the company needs to be involved. You know, what are your thoughts on this comment? How are you going to get management involved? You know, don't let people decide if they want to come to the TPM meeting. You know, they have to be at the meeting. The meeting starts at 3 p.m. So get them engaged in the process. You know, I feel this at a lot of plants. You know, you hear the old comment, but here's what I see. I've fallen and I don't want to get up because we're just used to the way things are. It's comfortable mediocrity. We got to change that style. We got to change what we do. And sometimes we all fall into this style sometimes because we're busy. You know, things are good enough and I'm busy. I don't want to change. Well, we got to get better. It's very hard to get up. It's very hard to move on. It's very hard to develop these processes, but do it slowly. But if you don't use these processes, failure is very possible. And maybe not failure. Maybe you're doing all right, but what if somebody next door, somebody else starts doing the same thing you're doing cheaper and more effectively? you're going to be out of business. You're going to be a failure. So TPM is changing people's thought processes. It's changing people's attitudes. And this is the challenge. Can we perform before our competition makes that change? That's the key. It's all about competition, because somebody that's doing the same thing you're doing may use this process and be more successful. You know, how do we get involvement? Steering committees, pilots, planning, education. You know, start small. Do a pilot test in one part of your plant. Once you get the success story, then move it to the other parts of the plant. Reassurance, increased job security, no reduction in personnel. That's what you have to make sure you do, is make sure, well, we're going to do TPM, but it doesn't mean we're going to get rid of somebody in the next few years. That shouldn't be why you're doing any reliability process. Sell the benefits, be a good salesman, more control, additional training, job satisfaction. Visit some other sites. If you want some success stories, or you ever want to know what the company that works on this, some of my customers will let you in, other ones won't, but maybe we can get you some good information or get you talking to somebody. You know, it's part of a company's plan to be competitive. What's your plan to be more competitive in the future? Your equipment improvement team, 2 to 3 operators, 2 to 3 maintenance personnel, engineering, supervision. You know, there can be one from each of these teams or process areas. But again, it has to be some engagement from all these people. Here's a slide I put in here just for working. You know, how do you work through some of these issues? You know, and so I put this chart in here just for you to use. But this is the employee improvement team responsibilities. You know, identify and resolve problems. Who does that? Develop objectives, plan goals. So this, I'll just put this data in here for you guys to look at and use if you're looking at doing a TPM. What makes your improvement team effective? They're cross-functional. We got people involved. They're trained. They're trained in problem solving and teamwork. RCM, RCA may be some other process used. They're focused on specific equipment. Able to measure progress. This is key. Get data. Supported by some advisory team. Meetings to this and involvement of this is mandatory. And again, don't make them long and strenuous. So, you know, meet for 1 hour a week. Maybe it starts off at 30 minutes a week. Develop procedures as a team. Don't develop procedures and then hand them to the team. Attitudes, cooperation at all company levels. Willingness to change. Trusting each other. You know, gathering new ideas. Active participation. Involvement by all is necessary. You know, at the one plant I went to, they made involvement mandatory, but then they made the meeting so interesting that more people wanted to be involved. Sensitivity to needs of individuals. You're going to have people in your plant that you're going to have to work with. Sensitive to needs of the organization, and commitment to make the process work. It's not something you're going to start TPM and then it doesn't work here. It works everywhere, but it's just that commitment to get it done. Skills, communication, team skills, leadership skills, problem solving and analysis, understanding change, training skills, planning and conducting meetings, all skills we need to have a good TPM program. So what's the biggest challenge to start a TPM? It's culture, right? What's the culture at your plant? Is there an age culture? Do you have union? What are those current practices you have to change? What about resources? You know, who's available to do what? You're all very busy right now, but who's available to do what part of TPM? That's why it's not a 1-person or a 2-person operation. Get everybody involved. And then your people. What's your people skill levels? What kind of training do we need to do? All biggest challenges to start a TPM program. So that concludes our webinar for today. If you have questions, again, you can email those to me. Justin will send you a PDF of the slide presentation. It'll be available, and of course the download of this presentation. So I'm hoping webinar 10 was some help today with some ideas. I'm hoping everybody, I appreciate everybody getting on the call today. And again, we'll have our schedule out for the 2018 webinar series. But and if there's suggestions or improvements that you'd like to see in the webinars, please email us and let us know that as we're planning our next year's presentation. Like I say, next year we're going to have some other speakers. We're going to have a guy from New Zealand talking about motors and VFDs next year. We're going to have somebody from CMMS Data Group talking about effective CMMS use. So lots of good topics coming up for next year's webinar series.